Hello, everyone. Welcome to this session on a course. Hello, everyone. Welcome to our course on minerals and energy resources. In this section of geography, we will explore some of the most important resources that support our daily lives and fuel our economy. We often hear about the metals like iron, gold, and copper, sources of energy like coal, petroleum, solar power. But you have ever wondered where these resources are coming from, how we extract them, and why they are so crucial to the modern society? Minerals are naturally occurring substances with a specific chemical composition found in the Earth's crust. They can be metallic, like iron and gold. They can be like limestone, non metallic, gypsum. The minerals are the raw materials for industries, which produce everything from construction material to technology components. In this course, we will discuss what minerals are and the types of minerals based on their properties and uses, how minerals are formed and distributed across different regions, energy resources which can either be renewable like solar, wind, or non-renewable like coal and petroleum. And we will also try to understand the importance of conservation, as many of these resources are limited and they take millions of years to form. By the end of this course, you will have a clear understanding of why minerals and energy resources are the backbone of industrial development and how our use of them impacts the environment. Let's dive in and explore this fascinating world of minerals and energy resources. Welcome to the course once again. See you in the other side of the section. Hello, everyone. Welcome to the session on minerals and energy resources. So, we all learned that minerals and energy resources are very important and very crucial for our day to day life. So, you can see here, we use different things in our lives. The different things in our daily life made from metals. So, can you list down few of them which you use in your house made of metals? Let us have a quick activity where you will list down few of the things which you can see around you in your own house which are made of metals. Where does these metals come from? The metals, iron, steel, like these metals, from where are they coming from? You have studied the Earth's crust. That Earth's crust is made up of minerals embedded in the rocks. So we have these minerals from the earth. Various minerals or metals are extracted from the minerals after proper refinement. So this brings us to the point that minerals are very, very important for us. They are indispensable part of our lives. almost everything we use today, from a tiny pin to a towering building or a big ship, all the made from minerals. The railway lines, the tarmac, the roads, our implements, machinery, tools, cars, buses, trains, aeroplanes, whatnot. All these things use one or the other forms of the minerals. Now, coming to manufacturing of minerals, in order to manufacture the minerals, we need lot of the power resources. These power resources help us, which are coming from the earth. Now, even we eat the food that contains minerals. In all stages of development of human beings, the use of minerals for their livelihood, for the decoration purpose, for festives, for religions, and for the ceremonial rites. So, in our day to day life, this brings us to understand that minerals are indispensable part of our life. Now, when we say minerals are very important, very useful for us, what are the minerals? Are you excited to know what are the minerals? Let's learn what are the minerals. As you can see here, the question, what are the minerals? What are the minerals? The minerals, any guesses? You can see here, the minerals as a homogeneous substance, naturally occurring substances with a definable internal structure. Minerals are homogeneous, same kind of material it contains, which is a naturally occurring substance, which is occurring in the nature. So you find it in the nature, which is definable through an internal structure. So the minerals are found in various forms in the nature, ranging from the hardest diamond to the softest talc. Why are they so varied? Why there is a lot of difference? So, in this section, we are focusing on the introduction part. That is, it is very clear for us that the minerals are very, very important for us. And coming to the meaning of the minerals, what is a mineral? The mineral is defined as homogeneous, naturally occurring substances with a definable internal structure. So they have an internal structure, they are available in nature, and you can get them only in nature. A mineral is a natural substance with a chemical and physical properties. So the composition and the atomic structure, what it has distinct results because the range of color, hardness, crystal form, luster, and density. So how they are different? Because on the physical and the chemical properties on which it is based upon, basing on all those things, the minerals are different because of the color, because of the hardness, because of the crystal form it is there, the type of form, the form of luster it has, and the density it holds. How much density is. All these factors make these minerals different from each other. Minerals can be broadly classified into three major categories. So let us see the categorization of the minerals. First one, the minerals based on the composition, we can classify them as metallic minerals. The minerals which contain The metals such as iron ore are called ferrous minerals. Ferrous means is a scientific name for iron containing minerals, which contain iron are called as ferrous minerals. Non-ferrous minerals we have, that is, which do not contain the iron component in it. So non-ferrous minerals include copper, lead, tin, bauxite. Whereas ferrous minerals include manganese, nickel, cobalt. Now, there are certain precious minerals known as gold, silver, platinum. Now, all these minerals come under the category of metallic minerals. Either it contains iron, ferrous group, non-ferrous group, precious metals group. So these three come under metallic minerals. So we have three types of minerals: metallic minerals, non-metallic minerals, and energy minerals. In metallic minerals, we have ferrous, which contain the iron, non-ferrous, which do not contain the iron component, and the precious metals like gold, silver, and platinum. Now, coming to the non-metallic minerals, example mica, salt, potash, sulfur, granite, limestone, marble, sandstone, etc. These are the examples of non-metallic minerals. Now, coming to the energy resources, the energy resources include coal, petroleum, and natural gas. So, we learned in this section what is a mineral, what is the definition of a mineral, why do we have different kinds of distinctions in the mineral occurrences, how are they classified? We learned in this section. In the next section, we are going to learn about the mode of occurrences of minerals. Stay tuned. We'll see you in the other side of the section. Welcome to the section. In the previous section, we learned what is a mineral and the types of minerals, the physical and the chemical conditions, like the hardness, the crystal form, the luster, the density. Then we are now going to look at the modes of the occurrences of minerals. Where are these minerals found? The minerals are usually found in ores. What do you mean by ores? The term ore comes from an accumulation of any mineral mixed with other element. So you don't get it in the pure form. You don't get it in the pure form. Minerals are usually found in the form of ores. Now there is a question. What is a ore? Yes. The term ore describes to us, that is, it is an accumulation. It is a combination. It is a mixture with the other elements. The main mineral with the other components, when it gets mixed, then it is called as ore. So all the minerals we get in one form or the other form of the ores. The mineral content of the ore must be sufficient concentration to make it extraction commercially viable. It should have the sufficient amount of ore because we need to extract it, and that should be a possibility. So there are types of the formation of the structures. Relatively ease with which mineral ores may be mined, which are easy, can be mined. The cost of extraction will be determining depending on the ore it is found. So it also determines the cost of extraction. Now, it is very important for us to understand how the formations are happening and what are the main types of formations through which the minerals occur. Minerals occur in various forms. So the first one, as we know, it occurs in the rocks. So let us see here, in the igneous and the metamorphic rocks, it may occur in the cracks, crevices, faults, or joints. The smaller occurrences of the minerals in the igneous and the metamorphic rocks is called veins, and larger ones are called lodes. Smaller ones are called veins, large occurrences are called lodes. So we have in the first place, in the igneous and the metamorphic rocks, we have them occurring in the cracks, in the faults, in the joints, and in the crevices. So in most cases, when the minerals are formed in liquid, molten, or in the gaseous form, are forced up towards the cavities of the earth's surface, then what happens? They will cool down and become solid in structure, and they rise. Major metallic minerals like tin, copper, zinc, and lead are obtained from veins and lodes. So the first form of occurrence is the veins and lodes. The veins and the lodes. In the igneous and the metamorphic rocks, minerals occur in cracks, crevices, faults, or in the joints, forming the veins, small occurrences, lodes in the large occurrences. What are the examples that we have for us where we can see this kind of minerals occurring? That is in the tin, copper, zinc, lead are few of the minerals where we can find they are occurring in the veins and lodes. Looking at the second type of rocks or the second type of occurrences of the minerals, that is in the bed or layers. It is in the form of bed or layers. In sedimentary rocks, a number of minerals occur in beds or layers. They have been formed as a result of deposition accumulated and the concentration in horizontal strata. So when it is there at the level, in the horizontal level, this is the vertical means like this, horizontal means like this. So in the horizontal strata, when it is get deposited over a period of time and that gets accumulated, then that is called a bed or a layer formation happens. What kind of minerals occur in this kind of occurrences? One is coal. Some forms of iron ore have been concentrated as a result of long periods under great heat and pressure. Another group of sedimentary minerals include gypsum, potash, salt, sodium salt as a result of evaporation in the arid regions. In the dry regions, we also find sodium salt, potassium salt, gypsum are also found. Major minerals to name, we can find them is coal and some form of the iron ore are found in the second mode of occurrence, that is beds and layers. As you can see here, in the beds or layers, we find the deposition as a result of accumulation on the horizontal strata. Example, gypsum, potassium salt, sodium salt in the arid regions, and you also find them coal and some forms of iron ore are found in this kind of the beds or layers occurrences. Stay tuned. We'll catch you in the next section. Welcome to this section on the mode of occurrences. So you can see the other mode of occurrence, there is a third mode of occurrence which we are discussing, is the residual mass of weathered material. Residual mass means it's another form of occurrences where it involves the decomposition of surface rocks. In the second form, we saw it the accumulation. Now there is a decomposition, means the weathering of it and removal of the soluble constituents and leaving the residual mass containing the ores. One example is bauxite is formed in this way. We already learned about the classification of the minerals. So we discussed about the metallic classification, non-metallic classification, and the energy resources in the section 1. So we are not again discussing the same thing. We'll go to the next form of occurrence. The next form of occurrence is the alluvial deposits. Now see here, the fourth form of occurrence. Certain minerals occur as alluvial deposits in sand. So the valley floors and the base of the hills, these are the places where the deposits happen. So these are called placer deposits. What are they called? The placer deposits. And generally they contain minerals which are not corroded by water, which means eroding, like gold, silver, tin, and platinum are the most important of alluvial deposit occurrences. Moving to the next occurrences, what we have is in the ocean water. We have many oceans around us. Yes. You all know the major oceans, right? Right. So the ocean waters contain vast quantities of minerals. So, but most of these are widely diffused because of the economic significance. However, common salt, magnesium, bromine are largely derived from ocean, and the ocean beds are rich in manganese nodules. So you get common salt, manganese, bromine, and also manganese nodules from the ocean waters. So these are the different modes of occurrences of the minerals. Stay tuned. We'll catch you in the next section. Welcome to this section on the modes of occurrences of the minerals. In the previous sections, we learned how they occur. Now let us look at an image of how these occurs in the visual format. So the occurrence of the minerals you can see here, as we discussed in the igneous and the metamorphic rocks, they happen in the form of veins, that is in the smaller portion, and if they are in the larger quantity like this, in a bulk quantity, if you find them, they are called as lodes. They are called as lodes. Similarly, you can see in the sedimentary rocks, that is the second type of occurrence, what we saw as a bed or a layer, which forms as a layer among the different layers of the rocks. Sediments get deposited to form the sedimentary rocks. Then we get this kind of rock. Under that, there is a layer that is called bed or a layer. Then we have the alluvial deposits, which are formed like this. Fourth type, we have the residual weathering, means half of the part is weathered away, the remaining part is there. That is called as residue, the remaining of the weathering. And in the oceans, we have the fifth type of the occurrence of the minerals. Stay tuned. We'll catch you in the next section. Welcome to this section. In this section, we are going to learn an interesting fact about what is known as the rat hole mining. What is rat hole mining? We all are aware, in India, all the mining activities are nationalized. So in order to do mining, we need to obtain the permission from the government. But In most of the tribal areas, especially in the northeastern part of India, minerals are owned by individuals or communities. In Meghalaya, there are large deposits of coal. So, they also have iron ore, limestone, dolomite. So, they have lot of minerals with them. But legally, they are bound to take the permission of the government. Now, as they are not feeling that it is necessary, they feel it is their own, or why should we take the permission? So, the coal mining in Joval and Chirapunji is done by the family members in the form of a long, narrow tunnel. They dig a long, narrow tunnel, and that long, narrow tunnel is known as rat hole. This mining, digging a long, narrow tunnel deep inside, a very small one, narrow one, where a one person can go or going without the permission of the government, is known as the rat hole mining. The National Green Tribunal of India has declared such activities illegal and recommended that these should be stopped forthwith. So, with immediate effect, these kind of activities should be stopped. That is known as rat hole mining. Is rat hole mining legal? Definitely, it is illegal mining, but it is still in practice in some parts which we might not know. Stay tuned. We'll catch you in the next section. Welcome to this section. In this section, we are going to see, is India fortunate or unfortunate with regards to the mineral deposits? India is fortunate to have fairly rich and varied mineral resources. These are unevenly distributed. They have peninsular rocks containing the reserves of coal, metallic minerals, mica, and many other non-metallic minerals. The sedimentary rocks on the western and the eastern flanks of the peninsula, that is in Gujarat and in Assam, they also have petroleum deposits in India. Rajasthan, with the rocky systems of peninsula, has the reserves of many non-ferrous minerals with them. The vast alluvial plain of North India is almost devoid of economic minerals. So you don't find much useful minerals in the northern part of India. These variations exist largely because of the differences that are existing in the geological structuring process and the time involved in the formation of the minerals. We will also further dwell deep in the major minerals that are found in India. The concentration of minerals in the form of ores is very important, but the ease of extraction, the closeness to the market play an important role in affecting the economic viability of a reserve. Yeah, you know that there is a mineral, there is a deposit, but are we able to spend the money to extract it? Do we have the technology? Is it close to the market? Is it viable to spend that much money? These all factors play an important role in getting the mineral out. See, if it meets the demand of the choices, then definitely it is a possible option. When this is done, a mineral deposit or a reserve, what is found, turns into a mine where the activity is done to extract the ore. Let's learn more details in the coming sections. Stay tuned. We'll catch you soon in the next section. Welcome to the section ferrous minerals. In this section, we are going to focus on ferrous minerals. What are ferrous minerals? The ferrous minerals account for 3/4 of the total value of production of the metallic minerals. So they are majority of the metallic minerals that we have. So in these metallic minerals, what we have, the minerals in which we have the iron content, that is called as ferrous mineral. Now they provide a very strong base for the development of metallurgical industries, the industries that are based on metals. The strong foundation for them is from the ferrous minerals. So India exports a substantial quantities of ferrous minerals after meeting her internal demands. After India has the sufficient amount of demands are fulfilled as per the need, then India also exports a significant amount of the ferrous minerals. So in that, the first category is the iron ore. Let us look at what is an iron ore. See here how the iron ore looks like. This is taken from Learning Geology, the source. So the iron ore looks like this. So you can see here, the iron ore is a basic mineral. What do you mean by basic mineral? Because it is required for almost all the industries. There are many industries which are dependent on this mineral. That's why it is called basic mineral or the backbone of the industrial development. So iron ore is also considered as the backbone of the industrial development. It is endowed fairly with abundant resources of iron ore. India has good amount of iron ore. India is rich in good quality of iron ores like magnetite and which is the finest iron up to 70%. Magnetite iron is the finest or very high content of iron up to 70% it will have, and this kind of iron ore, the magnetite iron ore, is used in electrical industry. So in the electronic parts they use this one, so electrical industry. Then we have the second ore, that is hematite ore. Hematite ore is also one of the most important iron ores, but this is slightly lower iron ore content than magnetite. Magnetite we have up to 70%, but hematite we have only up to 50 or 60%. So here we get little bit less quality, we can say, or the second type we can say. In 2018-19, more almost the entire production of iron ore, 97% occurred, means what we got is from Odisha, Chhattisgarh, Karnataka and Jharkhand. Remaining 3% only we got from the other states. So majority is produced from Odisha, Chhattisgarh, Karnataka and Jharkhand. Kudre in Karnataka means horse. So in Kannada language, Kudre means horse. So the highest peak in the Western Ghats of Karnataka resembles the face of a horse. So this has the hills like the hump of an ox, Balaidiya, and these names are given based on their appearances. So this is just a general information what we have. So what is the meaning of Kudre in Kannada? It is nothing but horse. Moving ahead, we will see the major iron ore belts. You can see the major iron ore belts on the map of India as well. Let us see them. See the major iron ore belts you can find in 4 parts. You can see this place, first place, the second part, second one, third one, fourth one. So you can see on the eastern border near West Bengal, Bihar, you find them, and you also find in the Chhattisgarh, Madhya Pradesh, Maharashtra border, then in the Ratnagiri and Goa, and Karnataka. We find this one. Let us see the regions now. So first region you can see Odisha Jharkhand belt, where you get hematite, the second quality of iron. We find here hematite iron is mined from Goa and Navamundi mines. Then we have Durga, Bastar, Chandrapur, Chhattisgarh, Maharashtra region. Very high grades of hematite are found here, and Baladila ranges of hills, Bastar district of Chhattisgarh. We find here almost 14 deposits of super high grade hematite iron ore is found, and from here they export the iron ore to Japan and South Korea via the Vishakhapatnam port. The third one we have is Ballari, Chitradurga, Chikkamangaluru, Tumkuru belt in Karnataka, where we have the Kudremukh located in the Western Ghats, and here you get one of the largest deposits of iron ore, where it is transported through slurry, transported as a slurry through a pipeline to a port near Mangaluru. This is a special feature. Here we are sending it in the form of a pipeline transport. So this is one thing which we have to note down. Then the last belt we have is that Maharashtra Goa belt, that consists of Goa and Ratnagiri districts of Maharashtra, which we saw in the map. And there we are, these ores are not very high quality, yet they are exploited and efficiently they are used. And the iron ore exported through Marmagao port. Through which port they are exporting? Through the Marmagao port they are exporting. We will learn many more details in the coming section. See you then. Welcome to this section on manganese. The manganese is mainly used in the manufacturing of steel and ferromanganese alloys. So the combination of steel happens with the combination of manganese, and also iron and manganese are combined, then only you get another alloys. So nearly 10 kgs of manganese is required to manufacture 1 ton of steel. In order to make steel, we need manganese. So manganese is also very important mineral which we need. And it is not only used in the making of steel, but it is also used for manufacturing bleaching powder, insecticides, and also in paints. So manganese also used other than in the making of steel and ferromanganese alloys. So you can see here which states contribute for the percentage. Manganese is largely found in the state of Madhya Pradesh in India. Then we have Maharashtra, followed by Odisha, then Karnataka, Andhra Pradesh, and other regions. Stay tuned. We'll catch you in the next section. Welcome to this section on the non-ferrous minerals. India's reserves, when they are coming to the part of non-ferrous minerals, they appear not much satisfactory. However, they have certain minerals which include like copper, bauxite, lead, zinc, gold, and they also play a vital role in the number of metallurgical industries, in engineering and electrical industries. Let us learn about copper and the bauxite distribution. First, let's begin with the copper. See here, copper is critically deficient in the reserves of production of the copper, especially in India we have less. Being malleable, ductile, and good conductor, malleable can be transformed. Ductile, you can make it like thin layers, and the good conductor of electricity is mainly used for electric cables, electronics, and chemical industries. So these three major industries we need copper. So the Balaghat mines in Madhya Pradesh, Khetri mines in Rajasthan, Singban district of Jharkhand are the leading producers of copper. So copper we need mainly for electrical and electronics sector or industry. Why we need? Because of its malleable nature, easily modification can be done. Ductile, you can take that into thin wires and you can use it as a good conductor of electricity. Moving ahead with the bauxite. You look at here the bauxite, though several ores contain aluminum, it is from bauxite, a clay-like substance, that alumina and later aluminum is obtained. So with bauxite only majorly we can obtain the aluminum part. Otherwise, we will not be able to obtain much. So bauxite deposits are formed by the decomposition of wide variety of rocks rich in the aluminum silicates. Because they are rich in the aluminum silicates, these are formed. Now, aluminum is an important metal because it combines the strength of metals such as iron with the extreme lightness and also the good conductivity and great malleability. So what makes aluminum an important metal? Because one, it is having the strength of iron, extremely light in weight, it is very good conductor of heat, electricity, and great malleability. Malleability means modifications can be done. So these all factors make it as a special and most important mineral deposit for us. So India's bauxite deposits are mainly found in Amarkantak Plateau, Michael Hills, and the Bilaspur and Khatni regions. Stay tuned. We'll catch you soon in the next section. Welcome to this section on the non-metallic minerals. The non-metallic minerals, we are going to learn about mica. Mica is made up of a series of plates or leaves. So it contains various layers in it. So it is easily split into thin sheets. That is one important feature. And these sheets can be so thin, 1,000 can be layered into a mica sheet of few centimeters. They are very, very thin sheets. With very thin sheets, they are useful, and mica can be clear, black, green, red, yellow, or brown in color. And the other excellent feature what it has is, due to its excellent dielectric strength, low power loss factor, insulating properties, and resistance to high voltage, mica is one of the most indispensable minerals used in the electric and electronic industries. Mica has certain special features. One, it is dielectric in nature. Both the ways it works. Low power loss. Very less amount of power is lost. Insulating properties and resistance to high voltage. Even the high voltage comes, it will not get burnt. So it can resist it. These are the special and unique properties which makes it as one indispensable mineral of the electric and electronic industry. Where do we find them? We find them in the northern edge of Chota Nagpur Plateau and Koderma, Gaya, Hazaribagh belt of Jharkhand are the leading producers. Apart from this, we also find some parts in Rajasthan, in and around Ajmer region, and also Nellore. We find the mica belt in Andhra Pradesh. So in India, we have 4 major locations where we can find the most indispensable mineral of electric and electronic industries. Stay tuned. We'll catch you on the other side of the section. Welcome to this section on the rock minerals. In the rock minerals, we are going to learn about the limestone. Now, limestone is found in association with rocks of calcium carbonates or calcium and magnesium carbonate. So, it is found in a combination of calcium and also calcium carbonate or calcium and magnesium carbonates. It is mostly found in the sedimentary rocks. It is a basic raw material for cement industry and also for smelting iron ore in a blast furnace. So it's highly useful in cement industry and also in smelting of the iron ore. Which states we find the deposits of the limestone? We can see here. First, majorly we can find it in Madhya Pradesh and Andhra Pradesh with a major share. Rajasthan with top 20, Madhya Pradesh 13, Andhra Pradesh 13, Chhattisgarh 11%, Karnataka 9, rest Telangana, Gujarat, Tamil Nadu, Maharashtra and others all together they account for 8% as per the 2018-19 statistical data. But stay tuned. We'll catch you in the next section. Welcome to this section on hazards of mining. What are the hazards of mining? Have you ever wondered the efforts of the miners making in life comfortable for you, for all of you, including me? What is the impact of mining on the health of the miners and on the environment? What is the impact? The dust, the noxious fumes that are inhaled by them, what they inhale, what they breathe, the miners, that makes them vulnerable to pulmonary diseases, the heart diseases, the risk of collapsing mine roofs, the roofs of the mine collapse, and inundation and fires in the coal mines are constant threat to the miners. Inundation, the watering, the water comes up suddenly, the fires, and the water sources in the region get contaminated due to the mining dust, due to the dumping of waste, due to the slurry leads and degeneration of land, soil, increase it and make it more river polluted. So all these acts are done by the miners not intentionally. Because they are working in the mining sector, they are forced to get exposed to such kind of situations. Now, it is very, very crucial to see that these unsafe standards have to be replaced with the safer measures. You see, over 50% of the coal belt mines are unsafe. This is a headline in the newspapers. Safety standards were not in place. So this shows very clearly that the lives of the people are not safe. It is very, very important to strictly implement the safety regulations and the environmental laws, essentially to prevent mining from becoming a killer industry of the miners and the people who are associated with it. This is a dangerous hazard of mining. Stay tuned. We'll catch you in the next section. Welcome to this section on the conservation of minerals. We all appreciate the strong dependence of industry and agriculture upon the minerals and substances manufactured. We all use them. But the total volume of the workable mineral deposits is an insignificant fraction, that is 1% of the earth's crust. We are rapidly consuming the mineral resources. We are continuously using the mineral resources. Now, as we required millions of years to get them acquired to form, the geological process that goes through for the formation of minerals is so slow that the rate of replenishment are infinitely small in comparison to present rates of consumption. We are eating too much, we are consuming too much. When you look at the rate of the geological process it takes to form them or replenish them, the mineral resources are therefore are finite in nature. They are limited in quantity and they are mostly non-renewable in nature. Yes. So we are using too much of them, but they are available too little for us. So rich mineral deposits of our country is extremely valuable, but they will live for a short time possession only. If we continue to use in the same way, going into the greater depths and decrease in quality, then we may face the scarcity of the minerals. So, as a concerted effort to be made in order to use our mineral resources in a planned and a sustainable way, as you know, we need to plan in such a way that our generation will not be devoid of the benefits. At the same time, the future generations which are going to come should also have their natural fair share of the minerals present for them. Improved technologies need to be constantly evolved to use low grade ores at low cost, and recycling of the minerals, metals, scrap minerals, and other substitutes may be made as steps to conserve our mineral resources for the future needs. Yes, it is our responsibility to have a concerted effort, a conscious effort to save our mineral wealth, because it takes a lot of time for them to get replenished. But at the rate what we are using them, what we are consuming them, is too high, too fast when compared to the rate of their replenishment. Stay tuned. We'll catch you in the next section. Hello, class. Welcome to this section on energy resources. Energy is required for all activities today what we are using. It is needed for us for various of activities, let us say to cook, to provide light, to heat something, to propel vehicles to move, to drive the machinery, whatnot. So for many things we need energy. Energy can be generated using the fuel minerals like coal, petroleum, natural gas, uranium, and from electricity. So, energy resources can be broadly categorized into conventional resources and non-conventional resources. We have the traditional form of resources from many period, very long period where we are using. The conventional resources include firewood, cattle dung, cakes. Then we have coal, petroleum, natural gas, both hydel and thermal power stations. When it comes to the non-conventional, non-traditional ways of using the energy, that is coming from solar, wind energy, tidal energy, geothermal, biogas, and atomic energy. Firewood and cattle are the most common ways in rural India for usage, whereas according to one of the estimates, more than 70% of the energy requirement in rural household comes from these two, the firewood and the cattle dung cake. Now, continuation of these is increasingly become difficult due to decreasing forest area because of the disappearance of the forest. because of the increase of deforestation, the availability of firewood has become really difficult. Moreover, using dung cake too is being discouraged because it consumes most valuable manure which could be used in the agriculture. So, in this section, we learned about the classification of energy resources into conventional and non conventional resources. Stay tuned, we'll catch you in the other section. Hello, class. Welcome to this section on the conventional sources of energy. As we learned in the previous section, there are two major classifications of the sources of energy, the conventional and the non conventional. In the conventional sources of energy, we have largely the coal. Coal is most abundantly available fossil fuel in India. It provides a substantial part of the nation's energy needs. So, India is largely dependent on coal for the power generation. It is used for power generation to supply energy to the industry as well as for the domestic needs. It is highly dependent on coal for meeting its commercial energy requirements also. The coal is formed due to the compression of plant material over the millions of years. Let us look at the types of coals that are available for us. You can see here, the first form, it is under the many trees and all, where it is getting compressed and we call it as peat. Second one, we call it as lignite. Third one, due to heavy pressure and over time, it becomes subbituminous, bituminous, and anthracite. Like this, there are different types of coals that is formed in different stages. So the time of the burial, the heat, the pressure that it is getting decayed in the swamps produce the peat. So the first category of coal is peat when it is produced under the swamp, which has a very low carbon and high moisture content, low heating capacity. Second one is lignite, very low grade brown coal, which is soft with high moisture content. This type of the coal, the principal lignite reserves are available for us in Neyveli in Tamil Nadu in India. They are used for generating electricity. Coal that has been buried deep and subjected to increased temperatures is called as bituminous coal. And when we see the other one, which is the bituminous is used for commercial use, whereas the metallurgical coal is in high grade bituminous coal, which has special value for smelting iron in the blast furnace. And coming to the highest quality hard coal, so that is known as anthracite. These are the four different types of coals what we saw and how they are formed. First one is very soft, highly moistured, and second one is not highly soft, but at the same time they are brown in color. So it is called lignite and it also has moisture. Whereas bituminous in two forms, the depth it goes, the bituminous has higher value in the smelting of iron in the blast furnace, and the anthracite is the hard rock coal where we get the highest quality of hard coal. So, depending on the softness, we categorize them on the time and also on the pressure where they are put on. So, India, we see rock series of two main geological ages. One, namely the Gondwana, over 200 million years age, and the deposits which only about 55 million years old. So there are two types of time period made of the geological ages. One type of rock series is found with over 200 million years of age, and the second category is or about 55 million years old. The major source for coal is the Gondwana coal, and which are metallurgical coal like the bituminous coal. Damodar Valley Corporation, which is found in West Bengal region of India, we get, and also in the Jharkhand regions, Jaria, Raiganj, Bokaro are the important coal fields. The Godavari, Mahanadi, Son, Varda valleys also contain the coal deposits. The second, the tertiary coal occur on the northeastern states of Meghalaya, Assam, Arunachal Pradesh, and Nagaland. Remember, coal is a bulky material, so which loses weight on use and it reduces to ash. Heavy industries and thermal power stations are located close to the coal field because you need to carry the bulk amount of the coal from one place to another place. That's why it is highly important for us to check the coal fields are close by to the heavy industrial region or to the thermal power plants. Stay tuned. We'll catch you in the next section. Welcome to this section on petroleum. Now, petroleum is another major energy resource after coal. We can call it as the second major resource after coal. It provides fuel for heat and also for lighting, lubricants, for machinery, raw materials, and for manufacturing industries. Various manufacturing industries, petroleum acts as a raw material. Petroleum refineries act as nodal industry for synthetic textile, fertilizer, and numerous chemical industries. So they act as the nodal, means the focus point for the synthetic textile industry, fertilizer industry, and chemical industries. Most of the petroleum occurrences are associated with anticlines and fault traps in the rock formations of the tertiary sector. So they are found in the rock formations where there are the anticlines or the fault traps that are found, and in the regions where folding domes occurs, the oil is trapped in the crescent of the upfolding. So on the upper folding of the rock, you find the rock on the top of the rock folding. The oil will be trapped here. It cannot move anywhere where it is getting folded here. So there it gets folded. So this oil bearing layer is a porous one with limestone or sandstone to which the oil may flow. Now, what is this porous limestone or porous sandstones? The porous means the small, minute holes that are present, the passages that are present. So these make the oil to flow, and the oil prevented from rising or sinking by intervening non-porous layer. So there is another layer under the porous layer. That layer is called the non-porous layer, non-hole layer. So from the top layer, when the oil is folded, from this there are pores which can make it go down, but below that there is a strong layer on this which stops the non-porous layer, which stops the flow of the petroleum. And petroleum is also found in the fault traps between the porous and the non-porous rocks. So between the porous and the non-porous rocks, you find them, and gas being lighter usually occurs above the oil. We also get gas, the natural gas, which is a bit lighter than the oil resource. So it is available on the upper part of the oil. Mumbai High, which is located in Maharashtra, Gujarat, then we have in Assam, are the major petroleum production areas in India, and they are located in the offshore of the western India. Ankleshwar is the most important field of Gujarat. Assam is the oldest oil field state of India. Digboy, Nahar Katia, and Moran Hagrijan are the most important oil fields in the state of Assam. So, in this section, we learned about the importance of petrol. What are the industries that are associated with petrol? How it acts as a nodal industry, a primary industry for other industries like synthetic, fertilizer, and numerous chemical industries. Then we discussed about the occurrence of the petroleum here. It occurs in the anticlines fault traps of the rocks between the porous and the non-porous rocks, the tertiary age, the foldings, the anticlines, the domes where these oil is found, and there is a layer of porous which is holding this oil, and below that which prevents the sinking or raising that is happening by the intervening of the non-porous layer. Petrol is found in India in three major offshore fields, which are located in the western India. Mumbai High, Gujarat, and Assam are the states. So, in Ankaleshwar is an important field for Gujarat, and similarly, Digboy, Nahar Katia, and Moran Hagrijan are the important fields in the state of Assam. Stay tuned. We'll catch you soon in the next section. Welcome to this section on natural gas. So, in the natural gas, where is it found? It is found with the petroleum deposits. As we learned earlier, natural gas is a bit lighter in weight when compared to the oil. So, it is released when the crude oil is brought to the surface. So, how does the natural gas that is found? The natural gas is found when petroleum deposits are brought up towards the surface. Then you get the natural gas. It is used for domestic as well as industrial purpose. The fuel is used in power sector mainly to generate electricity for heating purpose in industries, and also a raw material in many chemical, petrochemical, fertilizer industries. It is also used for transporting fuel, cooking fuel, and with the expansion of gas infrastructure, the local city that is there, the gas distribution network in the locally has emerged as preferable transport fuel and cooking fuel at homes. As it is grown, it has got a new market at homes as well as in the transport system. Now, India's major reserves, where do we find these major reserves? We find the major reserves in the fields along the west coast, which are supplemented by the finds in the Cambay Basin, along by the east coast. New reserves of the natural gas have been discovered in the Krishna Godavari Basin of Andhra Pradesh state. First 1700 kilometers long Hazira, Vijaypur, Jagadishpur cross the country gas pipeline was constructed by GAIL, Gas Authority of India Limited, which is linking Mumbai High and the Basin gas fields with various fertilizers, power, industrial complexes, and the western and northern India. Now, this artery provided an impetus and growth to the Indian gas market and the gas development, contributing to India's development. Overall, the gas infrastructure has expanded over 10 times from 1700 kilometers to 18,500 kilometers across the country through the pipeline, is expected soon to reach 34,000 kilometers, and a gas grid by linking all the gas sources consuming market across the country, including the northeastern states. So, like this, we have a major role to be played by the natural gas in the country's development. The way it is being pipelined and supplied across the country is showing a significant role in the development of the country. Stay tuned. We'll catch you in the next section. Welcome to this section on electricity. Electricity has a wide range of applications in today's world. That is, its per capita consumption has increased as an index of development. So, electricity is playing a key role in the country's development, which is acting as an indicator for a nation's development. So, electricity is generated mainly in India in two ways. One, by running water, which drives hydro turbines to generate hydroelectricity, and by other fuels such as coal, petroleum, and natural gas to drive the turbines to produce the thermal power. So, the source what they are using to move the turbines, if they are using water to drive the hydro turbines, it is called hydroelectricity. If they use the fuel such as coal, petroleum, or natural gas and drive the turbine to produce thermal power, then electricity is generated. So, there are two ways of generating electricity. Once the electricity is generated, is exactly the same. You don't find any difference between the thermal energy or the hydro energy. Hydroelectricity or hydel power, as it's first generated by fast flowing water, it is a renewable resource because you can use the same water multiple times. So in India, we have a number of multi-purpose projects like Bakranangal, Damodar Valley Corporation, Kopili Hydel Power Project, which are used for generating hydroelectric power. As we see the thermal electricity, the second one, which is used by coal, petroleum, and natural gas. Now, the thermal power stations use non-renewable fossil fuels for generating electricity. You need to know here, these are non-renewable fossil fuels, which means once you burn the coal, it gets converted into ash. We cannot use it again. Same way with petroleum, same way with natural gas. So hydel or hydropower, the water can be used multiple times. That's why it is a renewable resource, whereas thermal electricity by coal, petroleum, or natural gas is generated using non-renewable, can be used only once. Only one time we can use this fossil fuel. So this is the major difference. Let us see some of the power projects which are located in our country. Let us see them on the map of India. You can see here the black dots which are there. The black dots indicate for us the the thermal power stations. Delhi, Hadarjang, Panki, Baroni, Parchi, Raigad, Durgapur, Chandrapur, Rihand, Sagoli, Satpura, Karba, Amarkanta, Karodi, Nashik, Uran, Ramagundam, Kottagudam, Vijayawada, like that. And you have nuclear power plants in Thaiga, in Tarapur, in Kakrapura, Rawatbata, Naurora. So these are very few places where we have the nuclear power plants. Stay tuned. We'll catch you in the next section. Welcome to this section on non-conventional sources of energy. So the growing consumption of energy has resulted in country becoming increasingly dependent on the fossil fuels, especially like the coal, oil, and also the gas. As we know, these are non-renewable resources. Now, adding to this, the rising prices The cost also is growing up. So now there is a potential shortage, raising uncertainties about the security of energy supply in future, which in turn has a serious repercussions on the growth of the national economy. One, they are non-renewable resources. Secondly, we have the growth of the price resulting in potential shortage. And thirdly, it is going to directly hit a set of serious repercussions which is affecting the growth of the national economy. Moreover, the fossil fuels also cause a serious environmental concerns or problems like the pollution. Now, we are looking at the alternatives. Once there is an issue that has been raised, we need to figure out the alternatives. The human society has evolved like this. The issues it faces, then it tries to work out or figure out some solutions. Similarly, there is a pressing need for renewable energy sources like solar energy, wind energy, tidal energy, biomass energy, and waste material energy, which is coming from the biodegradable things. These all are known as the non-conventional sources of energy. What are these are called? The non-conventional sources of energy, the non-basic sources, non-traditional sources. Now, when it comes to India specifically, India is blessed abundantly with an abundance of the sunlight, the water, wind, and biomass. So it has the largest programs for the development of these renewable energy resources. Let us explore each one, first starting with the nuclear energy or atomic energy. It is altered. How do we get this energy? When you alter the structure of the atoms, when such alteration is made in the structure of the atom, then certain amount of energy is released in the form of heat, and this heat is used to generate electric power. When we change the electrons and the neutrons in the atoms, so you get certain amount of heat that is released. That heat is trapped and used to generate electricity. Example, what kind of atoms we use? Uranium and thorium are available in Jharkhand. Aravalli ranges of Rajasthan are used for generating atomic or nuclear power. Monazite sands of Kerala is also rich in thorium. So these are the three sites in India from where we can generate the atomic energy from the atoms. Altering of the atom structure results in releasing of the heat energy. So that is used or trapped to generate electricity. So that is the first form. And next one we are going to learn is the solar power. India is a tropical country which has enormous possibilities of tapping the solar energy. We use the photovoltaic technology, PV technology, to convert the sunlight directly into electricity. They are a different set of the layers of the glasses that are laid. They absorb the sunlight and they convert into electricity. Solar energy is fast becoming popular in rural and remote areas because some big solar power plants are being established in parts of India, which will minimize being dependent on the other things and also dependence on the firewood and the cow dung cakes, the dung cakes, which in turn will also contribute to environmental conservation and adequate supply of manure in agriculture. As we discussed earlier, the dung cakes are actually used as manure in agriculture because they are used as firewood. That is becoming a problem and shortage for the supply of manure. So this problem also is sorted, and also the environmental concerns are also addressed with the growth of solar energy. That's why government also is coming up and encouraging very heavy installation of the solar power plants or solar photovoltaic technology at every household, majorly in the rural areas, to ensure that it reaches to large sections of the people. Moving to the third type of energy resource that we have, that is the wind power. India also has a great potential for wind power. As you can see here, these are the wind vanes which are set up. The wind farm cluster is located in Tamil Nadu from Nagarkoil to Madurai. Apart from the states like Andhra Pradesh, Karnataka, Lakshadweep, Gujarat, Kerala, where we find important wind farms, and Nagarkoil and Jaisalmer are well known for effective using of the wind energy in our country, India. We have three more to go. Stay tuned. We'll catch you in the next section. Welcome to this section on biogas. The shrubs, farm waste, animal and human waste are used to produce the biogas for domestic composition in the rural areas. While this decomposition is happening, the organic matter yields gas which has higher thermal efficiency in comparison to kerosene, dung cake, or charcoal. So while you are decomposing this one, that releases an amount of gas through the organic matter while it is getting converted. So that gas is collected and used as energy. So biogas plants are set up at municipal, cooperative, and even at the individual level. The plants using cattle dung are known as gobar gas plants in rural India. So this provides twin benefits to the farmers. There are two major benefits to the farmers. One is it gives an energy, a form of energy. Second one, it is helping in improving the quality of the manure what they are getting. The manure that is used, that what they are getting, that manure quality also is increased. So the cow dungs plants or the biogas plants are created like this. A large vessel dome construction is done. So most efficient is the cattle dung among the biogas. It improves the quality of manure and prevents the loss of the trees and the burning of the fuel wood and cow dung, cakes, which also leads to environmental concerns, environmental pollution. Moving to the next type of the energy, that is the tidal energy. Oceanic tides. In the ocean, when we see the tides, they come with huge energy. So when they come with huge energy, that energy is used to generate electricity. So floodgate dams are built across the inlets where the oceans have an inlet. The tide water flows into the inlet and gets trapped with the gate is closed. When the huge gush of the water comes, huge flow of the water comes, they hold it and they use it. And once the water falls out of the gate, as it falls out of the floodgate, the water retained by the floodgate flows back to the sea via the pipe that carries it through a power generating turbine. So how is the power generated? Once you gulp that water and you store it, we divert that flow through a pipeline through which it hits the turbine with a force and it generates electricity. In India, we have the Gulf of Khambat, the Gulf of Kutch in Gujarat, the western coast and the Gangetic plains in Sundarban regions, which are ideal for using of tidal energy resources. In this way, we can use the oceanic tides to generate electricity, and it can be used any number of times. Moving to the last type of energy, the non-conventional geothermal energy. Geothermal energy refers to, geo means earth. The heat, the electricity produced by use in the interior of the earth, the heat that is coming from the inner layers of the earth, which is coming outside, that is used to generate electricity. That is known as geothermal energy. So geothermal energy exists because earth grows progressively hotter with increasing depth. As we go deeper inside, it becomes hotter where the energy is available for us. The geothermal gradient is very high temperatures as we have shallow depths. The groundwater in such areas absorbs the heat from the rocks and becomes hot. So it is so hot when it rises to the earth's surface, it turns into steam. The water from that layers is becoming very hot. As it reaches to the upper layer of the earth, it becomes like the steam, and that steam is used to drive the turbines and generate electricity. So there are several hundreds of hot springs in India as well. We used to generate electricity. Two experimental projects have been set up in India to harness the geothermal energy. One is located in Parvati Valley near Manikar in Himachal Pradesh, and the other one in the Puga Valley in the Ladakh region. So it is very useful to look at the alternative sources of energy because we may face the shortage of the supply of conventional resources because they are non-renewable in nature. Stay tuned. We'll catch you in the next section. Welcome to this section on the conservation of energy resources. Energy is basic requirement for economic development. Every sector of the national economy, let us say agriculture, let us say industry, transport, commercial, domestic, it needs the input and energy. Economic development plans implemented since independence necessarily required increasing amounts of energy to remain operational. So energy plays a very important role in every country's economic development. Every sector of the national economy needs energy. So from the independence period, there has been plans necessarily implementing to increase the amounts of energy. Now, as a result, the consumption of all energy in the farms has been steadily rising all over the country. Now, in this background, as the energy consumption is increasing, the availability also has to be increased. There is an urgent need to look at the sustainable path of energy for development. We need to promote the energy conservation, to save energy, to produce the energy largely, and also encourage people to learn to conserve the energy resources and increase the renewable energy resources, the twin planks of sustainable energy. One, the plank of the sustainable energy is to promote energy conservation, saving of energy. Second aspect, to use the renewable energy resources like the tidal energy, geothermal energy, biogas plants, like that. India is presently one of the least energy efficient countries in the world. Yes, it is a fact. As a matter of fact, it remains the same. And we have to adopt cautious approach for the judicious use of our limited energy resources. As concerned citizens of India, we can do our bit by using public transport system instead of using individual vehicles, switching off to electricity when it is not in use, when you switch off the electricity, when you are not in the room or in your place, as a responsible citizen, you can do this one using the power saving devices and using non conventional sources of energy, so that we can all believe in the energy saved is directly equal to the energy produced. So, in this journey of the different minerals and energy resources of India, we learned about what is a mineral, we learned about what is a mineral, what are the different types of minerals, the classification, the modes of occurrences of the minerals. Then we learned about the different types of minerals, the ferrous minerals, non-ferrous minerals, energy resources, how they occur, where they occur, and how to conserve the energy resources, why it is important to conserve the energy resources. And we also learned some suggestions as a responsible citizen of India. How do we save energy, which is equal to the energy produced? Thank you very much for subscribing the course. We'll meet you soon in the next course.